Hey guys, so in the last section we looked at functions in the form of a roller coaster and different types of functions and how we can determine what intervals in each function is increasing over which interval my function is decreasing. And so today we're going to look at something called an average rate of change, which is a ratio that compares how one quantity changes on average relative to the change in another quantity. So if we think back to the roller coaster example, instead of looking at is it just increasing, decreasing, now we're looking at how much is it increasing, how much is it decreasing, what is the average rate of change, how fast is it changing. Now for a linear function, if it's a line, the slope is actually the rate of change. Remember, we define slope as change in y over change in x. But we can also find the average rate of change for nonlinear functions as well by simply drawing what we call a secant line between the 2 points. So if we look at the diagram on the right side, we have a curve here. Let's say I want to find the average rate of change. How is y changing as x changes between this point and this point? Now, because it's a curve, it's not going to be exact, but I want to find the average. So all I'm going to do is I'm going to draw a straight line. I'm going to draw a line between these 2 points and calculate their change in y and their change in x, which happens to be the slope. And that will give me the average rate of change between these 2 points, even if it's on a curve. And so I can see that as x increases, y also increases, and my change in x between the 2 points is 4 hours, and my change in y is 244 miles. So I can say that the average rate of change for this function between these 2 points is that there's an increase of 244 miles. It's an increasing interval for every 4 hours. So finding the average rate of change is simply just finding the slope between the 2 points that we are given. And so if you're given a graph, it's very easy. All you're going to do is count. You can count from the graph, or you could use the 2 points that is given to you. So to determine slope, remember slope m is rise over run. Rise is up and down. That's the change in your y value. And run is left and right. That's the change in your x. And so we always read our graph like a book, from left to right. So if you're looking for the average rate of change between 2 points on a graph, you always start with the point on the left and think about what the change is going from the point on the left to the point on the right. So in this case, the average rate of change between these 2 points, 0, 7, I'm going to start with that, and 4, 4. Now, option 1, we can count the slope. It looks like we went down 3 and over 4. So my average rate of change is minus 3 over 4. 4 as x increases, y decreases. It's a decreasing interval. So my average rate of change is my slope, which is negative 3 over 4. Okay, now if you don't have a graph, but instead you're given a table, all you need is 2 points to find the slope. We have what we call the slope formula that you might recall from earlier this year. To calculate slope, all it is rise over run. So that's all you got to remember. Rise is the change in y. So you're going to subtract the y values, divide by the difference of the x values. Now it doesn't really matter which point you pick to be x1, which point you pick to be x2 and y2, but you got to be consistent. So all we need is 2 points to calculate the slope. If you have a table and it doesn't specify, you can pick any 2 points that you want. So for example, if I want to use 1, 0 and 2, negative 3 to calculate the slope, then I'm going to use my slope formula, and I'm going to say that 1, 0 is my x1, y1, and 2, negative 3 is my x2, y2. So I'm going to subtract my y's, negative 3 minus 0, divided by, now if I do negative 3 minus 0, make sure you're consistent when you're subtracting the x's. We got to do 2 minus 1. So that's going to give me negative 3 over 1 and my rate of change or my slope is just -3. And I could have done the same thing on the left side with the graph. Instead of counting my units, I could have subtracted my y, subtracted my x's, and divide. Doing it the same way, I could have done 7 minus 4 divided by 0 minus 4, and I would have 3 over -4. And when we have the negative, we always bring that to the top number. Okay, so average rate of change is just the slope. Regardless of whether it's a line or a curve, we can find an average rate of change by drawing a line between the 2 points that we're looking for and calculating their slope. So let's look at the different types of slopes that you're familiar with. Let's do a quick review of that. We know that if we have a line or a curve, we have a line that goes up from left to right, always reading my book from left to right and reading my graph from left to right. If it goes up from left to right, we have positive slope. If it goes down from left to right, we have negative slope. If it's a horizontal line, think of flat ground. Remember, we talk about slope as steepness as well. When it's flat line, it has a slope of 0. And then when it's a vertical line, it has a slope of undefined, and it's also written on the top. Okay, so let's look at an example now. Let's go back to our roller coaster example from the previous section, and let's look at that again. But instead of looking at intervals in which it's increasing and decreasing, which you hopefully can see very easily now, roller coaster coming down, decreasing, going up, increasing, we're going to talk about what is the average rate of change in its height. How fast is it increasing? How fast is the height changing given time? So in part A, it's asking you, what is the average rate of change of the height of the roller coaster? How fast is the height changing with respect to time between 7 and 12 seconds? So we look at our graph. Remember, again, we're going to label our x as time in seconds. And then our y, we're going to say is height in feet. Okay, so at 7 seconds, let's see where the height of my roller coaster is. So 5, 6, 7, looks like that's this point right here. So at 7 seconds, it looks like it's about 6 feet. Okay, and then at 12 seconds, so 10, 11, 12, looks like it's at a height of 10 feet. So 12 seconds, 10 feet. I'm going to write these down as ordered pairs, comparing my two variables. And if I want to find the average rate of change, well, you know that my roller coaster is increasing. Okay, between these 2 points, how fast is it increasing? How much is the height changing with respect to time? All I have to do is draw a line that connects these 2 points. And I'm looking for the average rate of change, the slope of this line, which will give me on average, because I know that it does look like it's slowly going up and then it goes up faster, but on average, how fast is it going? So all I have to do is calculate the slope. So m, my slope, and I have 2 points, is going to be change in y, so the change in the height, 10 minus 6, over change in x, 12 minus 7. And that gives me 4 over 5. And with respect to our context here, the numerator represents the y value, so that's 4 feet for every 5 seconds. That's my average rate of change. Between 7 seconds and 12 seconds is moving at a rate of an increase of 4 feet every 5 seconds. Now, let's look at another interval. Okay, what is the average rate of change of the height with respect to time when x, which represents time, is between 12 and 16 seconds? So just written in a different way as an inequality, but let's consider that now. At 12 seconds, we had already said it's at 10 feet, right? So that's this point that we're going to reuse again. And then at 16 seconds, right here. Just going to estimate 16 seconds. It is at, looks like it's at 6 feet again. Okay, so now if I want to find the average rate of change, now I can see that it is decreasing. So my average rate of change is going to be negative because I am decreasing in height. And I'm going to, again, connect these 2 points and find the slope between these 2 points to calculate the average rate of change. So m is going to be equal to 6 minus 10, y2 minus y1, subtract your y's, and then subtract your x's, and 16 minus 12. 6 minus 10 divided by 16 minus 12. Which is going to give us negative 4 over 4, which reduces to negative 1 over 1, which is just negative 1, okay? And then with respect to the context of this problem, we are going down, we're losing 1 foot every second. So we are decreasing now, and the rate of change is minus 1 foot every second as we go down. Now, if you look at the roller coaster, it looks like starting at 12 seconds, right? That is a critical point. That's our relative maximum. Remember, relative max, not the max, but the highest point relative to all the other points near it. Now, starting at that point, it looks like my roller coaster continues to go down until it gets to the ground and the ride ends. But if you look at how much it's going down, it looks like it's going down quicker during this interval, right? It's more steep. And then as it keeps going down, it's going down slower over this interval. So even though both of these intervals are decreasing intervals, the average rate of change is not the same. It's going down faster in one interval and it's going down slower in another interval. So if we want to calculate the average rate of change with respect to time between 17 and 23 seconds, let's take a look at that. At 17 seconds, okay, I'm going to estimate it to be at 5 feet. So 17 seconds, it's at 5 feet. And then 23, it looks like it's at 2 feet. Okay, and now I'm going to calculate that average rate of change. Again, by connecting these 2 points on the graph with a secant line. Not letting me do it, so I'll have to do it by freehand. And just calculating their slope, which will give me my average rate of change. So m is going to be 2 minus 5, which again is going to give me a negative because I am decreasing in height, over 23 minus 17. That's going to give me negative 3 over 6, which reduces to negative 1 over 2. And so you can compare, over this interval, we are actually losing 1 foot every 2 seconds instead of every 1 second. So if we compare these two, even though they are both decreasing intervals, the average rate of change is definitely slower in the second interval, where it's starting to slow down. We're dropping 1 foot every 2 seconds instead of dropping 1 foot every 1 second. So that's what the average rate of change is. Okay, that's using a graph. Now let's look at an example of a table. Now we're talking about movie tickets. I know you haven't gone to the movie theater in a long time, but here are some data, real data, that shows the price for a ticket to a movie theater in North America for selected years is shown below. So you know that you can see that in 1987, the price of a movie ticket is $3.91. And then in 2009, it's at $7.50. And now, 2020, I want to say it's about $10, $12 per movie, depending on what type of movie you see. So we want to find the average rate of change of ticket price with respect to time over the period of 1987 to 1999. So these are the 2 points that we are looking at. Okay, obviously prices don't always change every year. So every few years it'll jump up a few dollars, but we want to find the average rate of change. Between these years, how much on average is it increasing? And so X is our year and Y is our price, because the price depends on what year it is. And to find the average rate of change, again, we're just going to find the slope between these 2 points if I were to graph them. So slope is change in Y over change in X. So the change in the price is from $3.91 to $5.06. So we want to see what the difference is. And then how many years has passed between 1987 and 1999. We want to see the difference in the number of years as well. So if I subtract, that's going to give me $1.15 in over a span of 12 years. That's the average rate of change. $1.15 in 12 years. That's really good. And if I divide it, if you want to divide it, you can look at it differently and say, well, if I divide it, that means $1.15 divided by 12. That will tell me how much increase there is in price tickets every year. So if I divide it, just to give you an idea, and round it to the nearest cent, it's basically about 10 cents for every year. Between 1987 to 1999, prices increased by roughly 10 cents a year for movie tickets. Okay? And then one last example that will help you with your practice, the last Delta Math practice activity that you have to do, is comparing average rate of change in intervals. And this is an SAT problem that I took from one of the practice tests. All you have to do is read the graph and compare over which intervals. Is it increasing the most? Is it decreasing the most? Etc. So this compares the number of 3D movies released based on the years. And as you know, in recent years, there has been more and more types of 3D movies, and so you can see that in 2003 there's hardly any, and then in 2011 there's like 45 3D movies released every year. So according to the line graph above, between which two consecutive years, so that means 2 years one after the other, was there the greatest change in the number of 3D movies released? So we're just looking for the highest rate of change. Between which 2 years is the increase the most significant? And you can clearly see on the graph that this is the most significant change right here, because it has the steepest slope. And so we always compare average rate of change with slope. So between 2010 and 2011 is where the highest rate of change in 3D movies released occurred. So quick summary, average rate of change is just the slope between 2 points, regardless of whether it's a line or a curve. If you have a graph that's a curve or a line, to find the average rate of change, pick your 2 points, calculate the slope. If you have a table, again, you're going to use your 2 points and calculate the slope.